Всем привет.
Hello, everyone.
Максимов Михаил.
My name is Mikhail Maximov.
Отдела развития технологий компании.
I'm the leading expert of Positive Technologies department, and I deal with the development of extension language and processing. Sorry, the microphone doesn't work. We can't hear what he's... Sorry, microphone is not on.
Всем привет.
Hello, everyone.
Меня зовут Никитин Андрей. Я
My name is Andrei Nikitin. I'm the head of the compilers
развитием
team. We support and
нашего языка.
development of compilers. And for our language today, we would like to talk about what is DSL and why would you need it. And we'll tell you about our experience, what problems we encountered, and what we did to solve the problems we had in our area. First, I would like to talk about the area that we work with. Most of you never heard of it. So what is CM systems? These are solutions that help us centrally collect the events, analyze them, monitor them, and store them in databases in order to solve the issue of collecting events of information security. Everybody knows that any software, they do logs, logging those events that are happening in the infrastructure. So, and the examples of information security events, this is creating the user, entering the system, exiting the system, and changing the configuration of the system. And based on those events, we can understand what in our infrastructure going on, and in order to automate it, we use CM systems. And their main goal is to detect the events of information security and keep them in the structure. So what are the typical services of CMs systems we have to process events? This is the normalizer. Because all events that we see and collect from different software, they're different in format, not any content. There is no any one single standard that everybody, all vendors would meet. And our goal is to transform such events to one sort of format so other services could process them and we could analyze those events. Also, the second one is aggregator, because oftentimes we see situations when there is some source that generates information security events and then it begins to spam the same events for different reasons. And our goal is to reduce the noise, to aggregate events at similar times, and just to keep the system free of noise, and so that the noise for our operator would be minimal. Also, enricher. In the process of work of the system and all the systems of the infrastructure of the company, we accumulate the data in the context of our procedures, and when you get new events in the system, we can enrich the new events with the context we have, so that our operator could have more information about what's going on in the infrastructure. So an enricher solves this issue. For example, there can be some references of critical users, or maybe it can be deciphering of some digital coding and some stuff. And the most interesting one is a correlator. The main purpose of correlator is to look for events in the thread, and which will tell us that was unauthorized impact on our infrastructure, and so that such sequences we could identify in this thread, we need to provide special rules of detection. So who are the users? This is a person who well versed in information security, knows how to analyze events, analyzes patterns that you can find in the thread, depending on the role in the organization. It can be operator, analyst, or specialist in information security. But there is a nuance here. They might not have an experience in programming of common languages, but we need to give them the rights to develop such rules. And what are the basic requirements to the rules, to the guidelines on the side of the user as part of our area? This is a quick writing and a setup of new rules, an adaptation of the rules that we already have, depending on the changes of the infrastructure, and of course, the easy understanding of what the code is, so that they could easily adapt the code. And to do this, we need DSL. What is DSL? This is domain-specific language, or it's a custom language, custom to the object that it works with, so on a high level of abstraction. In comparison to the general language, what perks it can give us. So for our users, it's much easier to write the code, and of course, it's less time to development and the adjustment of the code, and also performance. So of course, we can hide some stages of optimization of our area, so and we can get some perks in performance. Now, quality control, because the user will have less chances to make mistakes. And of course, given the area, so we use special tools to set it up. And also, it is easy to learn how to do it, so they don't have to have experience how to program in the common languages. They just have to know their area, but also it's about understanding the specific area. You have to well understand the task of this specific area, and you have to study quite a bit of cases that you will be dealing with. And that's why it has such a high cost of designing and realization. And it's also maintenance and the development of the language along its life cycle, because the requirements may change, users may have different wishes, different needs, and for all of this you should be able to adapt. And in order to process the events on the thread, we developed extraction and processing language, XP, and each notation has its own service, and it allows us to solve problems based on what service they use. And let's look at the code that is written in our language. So, normalization rules. You can see the original event. It was a text event, and it says that the connection was closed. So we need to take this text event, and the first section of our rule is parsing. Here we use mechanism of so-called formatted lines, with which you can describe the format of the pattern, and using tokens you can extract some parts of it, and from event to event they change. So, and we find the tokens. After parsing is done with this data, you can do arbitrary things, what you want to do. So in the second part of the rule, and in more detail, I can give you the example. Here, we compare the level of importance of the event using terminology that we use in our area to normalize the event with switch case. And here's the example of the normalized event, and with the pre-installed attributes. And each attribute is responsible for certain parameters that are important for our specific area. And here you can see several groups. In our taxonomy, there are many more. Here, I highlighted a couple of them. To describe the event, we use subject-object model. Each original event, we use like an object with a given status. We have a connection successfully closed.
Еще информация о хосте, с которого мы
And in this group, there is information about the host that we got it from. Then aggregation rules.
также две секции.
Here the same thing, we have two sections. First, on the thread, we need to select those events and describe the fields in which we're going to be doing the grouping.
Значение которого должно
The list of the fields that will have the events of the same type, then parameters of filtration,
в агрегации.
and the parameters of aggregation. First one is responsible for the number of events that we can put through the aggregation
Непосредственно агрегации.
without aggregation, so that to get the context of the initial event. And the second section
Указанный промежуток времени.
gives you the number.
Итак, правила обогащения. Точно так.
Enrichment rules, the same thing, two sections. First, we filter them.
Интересные нам события,
We select the interesting events,
который это
and then we apply the code to them that modifies the event.
рассматриваем кейс,
In this case, we look at the case when we have a deciphering of the
чтобы облегчить нашему оператору жизнь.
that deciphers abbreviations to ease the life of our operator. And here the rules of correlation.
Достаточно
Here we look at the case, a pretty simple one.
удаления учетной записи
It's the creation and removal of the user account.
на поток.
First, we need to select it on this thread, then we put it in the basket, so to speak, and then we'll look
События сгруппировать,
in order to group the events.
соответствующий ключ.
So we produce a key.
И по имени пользователя.
We group it by host and by username.
Фильтрации, где мы
And filtration section where we put the parameters, how we're going to select the events on the thread. As soon as we filter the event that we need in the basket, we need to have a targeted chain, and the chain is pretty simple. We use the operator, and then we remove the user account after some time. And after we collected all the necessary chains, we need to communicate it to our user. We need to form another event that will tell the user about it. So we have two mechanisms. First, these are the processors that we apply to the initial events, and we can run the XPO code, and it's a pretty simple case. And here you just save the data from the initial events, and that apply our new correlation to give the operator our full context. So we give the information to the user of what the user account and on what machine, and what the user actually deleted.
Посмотрим примеры корреляционных цепочек.
Also, the correlation chains here. In first chain, you can see that the operator
То есть в данном кейсе нам
changed. In this case, for us, the order is not important. It's just a number of events for a certain period of time. Also, we have
is different, который задает поле, которое
who is different. They put the field there that the value of it will be
а во второй цепочке
different for all the events that are in the chain. In the second chain, we have the optional events out of 3 events, and only one of them is mandatory. 2 of them are optional. And if these optional events are in the chain, then we will be able to give our operators some additional context that we can extract from these events. And here's the example of such context. You can see that expert here described how he find the marker online. If the marker is found, then in context field for our operator, we add information that this case that they used an unknown tool.
Итак, мы приняли
So,
решение разработать свой DSL,
we made a decision
дать нашему
to develop
удобное решение его задач.
our solution so that our user would have a convenient solution for the tasks. First, we need to analyze the specific area. And this is a stage where people want to save
Много нюансов может возникнуть впоследствии.
money, and there can be nuances if you do this. So if you have a chance to
Лучше это, конечно, сделать.
engage system analysts to this stage, so please do that, because if not, then you'll have to work with this on your own, and the developers team will have to do that. And there are many details here that I would like to draw your attention to.
Непосредственно доступ
First point is this access of the experts to the specific area, those who have great experience and they know all the nuances and
Подводные камни зачастую
all the stepping stones. All these nuances and stepping stones, they usually change the solutions that you're going to be making, decisions that you're going to be making at this stage of development and design.
постоянный и плотный диалог с пользователем.
This is a very close dialogue with the users of the language because
Возникать какие-то
in
вопросы,
any case, you'll have some questions during design stage.
ответы во многих
You'll have to get the answers to them, so you'll have to
предлагаемое вами решение, оно им
get in touch with the users and if they will want the solutions that you're going to offer to them. This is a great number of practical scenarios because practical scenarios,
нюансы,
this is where you test all the nuances and then they will affect all the further stages.
степеней свободы
And then the degree of freedom in the DSL for the users. This is
какую сторону
declarative approach actually, and
больше степеней свободы даете, значит,
the more
больше возможностей
freedom you give the user,
которые вы заранее в своем языке
the
не
more
предусмотрели. Но в то же
possibilities they have to
таким своим кодом
solve certain issues, but
производительность. А компания
users using their code, they can increase performance.
решения. Соответственно, меньше степеней
So
свободы,
less freedom,
возможности по оптимизации, но
more chances of optimization,
в этой области придется дорабатывать язык, выдавать, соответственно, пользователям.
and you will have to work more on the language to give users more features.
Мы разобрались с предметной областью, и можно...
So we spoke about specific area. Now designing the
приходилось
build.
нам сталкиваться.
I'll tell you what we encountered
Вспомним,
with example of
на
normalization.
каких этапах стоит нормализация.
So what stages normalization has? It's
Разбора события и
analysis of the event
нормализованного. Вот.
and forming the normalized event.
Части, они,
These two parts, as you can see,
по сути, это
they're significantly different from each other. These are two different languages within one rule.
описание
One of them is a declarative description of the texture of the
инструкций.
event, and then imperative sequence of instructions how the event should be formed.
Разница, получается,
And the difference is
в первом
that in the first case, declarative part,
сопоставлении
the algorithm of comparison and analysis, so this is realization part, and the developer
усмотрения,
can choose it
а
on his own.
вот, а второй части
And the second part,
последовательность.
we have a sequence.
Так. Ладно, слайды как-то слишком вперед убежали.
Slides kind of ran ahead of me. So in the imperative part,
четко заданная
we have
инструкции пользователям, и мы ее
a list of instructions for the user,
в том виде, в котором
and we can do it only in the way it's written,
информация оптимизации.
except for transformation and
В
optimizations.
оперативной части
In the declarative part,
свои проблемы, то есть
there are
она удобна
other issues.
с той точки зрения, что
It's quite helpful for developers because they can give users of the language, they can give them some guarantees
время этому исполнения,
for the time of working with this, but
требования к дизайну самого языка.
there are
Вот, и
additional requirements for the design of the language. In the textual normalization in the early versions,
форматными строками
during the development, they limited themselves with the format
текстовое событие
lines. So when the textual event
линейной последовательностью
was
каких-то,
just a linear sequence of some fragments
где были константные части, то есть
where they had constant parts,
которые
some sublines that you can find in all events from the same source,
современные части, то есть
and some variable parts, some non-fixed
токен,
data.
принимающие
They were replaced with tokens
предопределенных там разработчиками форматов.
that take the value of the formats that are
Разбор
prepared by the designers.
Одним таким правилом
So one event with such a rule, so the event was happening during a linear time,
форматных строк
several format lines, they could be optimized by
Но
aggregating prefixes.
эксперты почти сразу же пришли с
Quite soon, experts
кейсом.
came to us with a case.
У них в событиях, ну, в реальных событиях оказалось
In real events, it turned out they have
опциональные части,
optional parts,
есть какие-то поля с переменным количеством значений,
and there are fields with the variable values.
без изменения языка. Единственным вариантом это
And without changing the language,
со стороны экспертов было
to support it
написать несколько формул
was to write several formulas for each
комбинаций. Вот.
possible combination.
Пользователей, так как DSL это все-таки про удобство пользователей, разработчики добавили квантификацию.
So developers added their quantificators,
Для этого пришлось
quantifiers.
перейти на другой алгоритм разбора
They had to use a different analysis algorithm.
с возвратом,
So they had the search with return,
медленнее и без
which is
гарантий
search with reverse, and it was slower.
по поводу того, там, по поводу времени выполнения. И вот
So
там был хороший пример,
there
который
was a good example there
почему-то промотался.
that for some reason was skipped on the slides.
Язык, он пытался прикинуться декларативным, но
The language seemed to be declarative.
до пользователя вот пользователю стали видны особенности реализации, то есть
But the user could see some specifics of realization, and depending on how
даже если это с точки
they
зрения
read the event, even if this event, in terms of logic,
описание, даже если с точки зрения логики описания событий будут эквивалентными,
and if the events were equivalent,
какие-то там незначительные детали вроде
some insignificant details like a quantifier
влияют на скорость разбора.
may impact the speed of analysis.
Ну, теперь пройдемся по этапам.
So now let's go through the stages of realization.
Языка был написан
Prototype of compiler was written in Python.
вот, я так предполагаю, это в первую очередь помогло
I suppose
дойти до
that
этапа, когда можно
it
показать
helped
экспертам уже что-то
to
работает,
get to a certain stage when you could show to experts something that works.
при этом
At the same time,
именно компилятор, он перерос прототип и попал в
this compiler kind of grew
довелось заниматься
over the prototype, and
поддержкой.
so I was maintaining it.
Там можно отметить несколько таких интересных моментов.
And there are several interesting points in it.
Что еще такого красивого получается в компиляторе на питоне?
So what else you can have on the compiler written in Python? Python, so parser was written like this. And
Динамический язык,
Python is dynamic language.
программирование,
It's
метапрограммирование.
metaprogramming,
Вот сделали библиотечку, которая позволяет
and we made this library
грамматику языка,
that explains the grammar of the language
обрабатывает.
right in the code, and then the code is processed,
Вот. И потом это все собирается в грамматику и генерируется парсер.
and then it's all aggregated in the grammar and generated parser.
Вот. И
So it's pretty compact and pretty
ориентированный, то
visible.
интерпретатор всего этого можно было сделать просто по
So, and the interpreter of all of this could be done based on the book
проектированию
Patterns of Design.
интерпретатор. просто рекурсивно обходим все дерево,
abstract
вычисляем.
interpreter. So, and this is how we do it and how we calculate it. And as I said, at the stage of implementing the compiler state as it used to be, and the interpreter was written in C++, and
Вот. А потом начался такой эволюционный процесс развития.
then we had the evolution of it.
Самое, наверное, основное это то, что мы всегда...
And the key thing here is that we always had an issue with the speed.
Суть продукта обработать большое...
Because the purpose of the product is to process as many as possible events.
При этом еще важно, насколько много источников продукт поддерживает.
And it's also important to see how many sources it supports. Experts write new rules, they clarify the old ones.
То есть у нас увеличивается размер.
So thus, we have the size of the code growing.
Вот. Так как интерпретатор был написан, ну,
Since the interpreter was written
достаточно просто с точки зрения использования подхода,
pretty simple in terms of the approach to it,
лежащие на поверхности решения,
there were some solutions, some obvious solutions.
который отвечал за разработку
Then the team that was developing this interpreter,
машину,
interpreters, so they came up with the machine, virtual machine.
это, в принципе, дало вот основной результат, который
And it gave us the main result.
нас устраивает.
And we're pretty much satisfied with this result.
При этом и интерпретатор байткода, и транслятор из AST
And both the translator and interpreter of the code
на их стороне, то есть компилятор.
were realized on their side, and the compiler was not affected.
Сейчас ускорение достигается за счет просто
Now
компилирования и точного.
we get the acceleration by profiling the and optimization,
Но у нас еще было несколько не совсем удачных попыток.
but we had some not so successful attempts when we had the acceleration and
Отказаться от
attempts to
самописной виртуалки.
reject self-writing virtual machine. We tried to use LLV JIT.
LLVMIR,
We tried to generate LLVM, compile it, and to launch machine code.
это не пошло дальше прототипа, потому что
It didn't go further than prototype
стоимость этой разработки
because the cost of the development turned out to be
виртуальной машины, то есть
much higher than the virtual machine.
виртуалку там
And if
за несколько месяцев,
one developer does the virtual machine for several months, then
человек достаточно на долгое время в этой задаче закопался.
but with this task it took them much longer.
Еще пробовали использовать WASM,
They also tried to use
потому
WASM,
что
WSM,
давно появилась,
because the technology has been around for a while.
появилось много зрелых реализаций, есть из чего выбрать.
There are lots of pretty mature realizations, and it's again they used
У нас
the virtual machine, but we didn't manage to
синтегрировать ее,
integrate
синтегрировать WASM таким образом, чтобы не потерять
WSM in such a way just not to lose
из-за
the performance capabilities
в WASM
because of the approaches to security, and we lost something on the border. We'll time in more detail.
уже
Will
рассказывал мой коллега,
my colleague told you about this story?
он руководитель группы разработки рантайма. Вот
Evgeny Predakov, head of the runtime development group, told about it in more detail, and this is the link to his work. Also, the compiler was rewritten for the same reason. In the first place, more rules means more work,
Python, как известно,
and Python, as you all know,
не особо отличается скоростью.
can't brag
К тому же
its
за это
speed.
время
And also, over this time,
новые задачи, то есть компилятор нужно
some
встраивать в
new things appeared. The compiler had to be embedded into other products where the code wasn't written in Python.
решение было
So, other than rewriting, the only
процесс.
solution was to launch it as a process, as a utility. So we compiled the compiler on C++.
Проблемой было то, что
The biggest problem there was that over this time, the language has developed quite a lot, and the language description was spread across, wiki pages. It was difficult to rewrite the compiler at one go in such a way that the user code shouldn't be broken. We had some external users,
риск был такой,
and the risk was such
что их код перестанет
that
работать по
the
непонятной причине,
code might stop working for a reason unknown,
менять.
and one would have to choose something, to change something. So the solution for that was to write more tests, and we were fixing failures on the new compiler. Now we went further.
Информацию о языке,
We collected all the information about the language in the same place
языка,
and basically wrote the language specification
всех конструкций языка,
as kind of a semi-formal expression, description of all the constructs of the language in such a form that the programmer could almost rewrite it as code and to get a more or less working interpreter.
тестировщикам для
It was also convenient for testers,
подтвердить или опровергнуть.
so as to confirm or deny that they have found some bug.
Как уже говорилось, DSL это для в первую очередь, что пользователь.
DSL was mostly used for the user convenience.
Важно
And so in the implementation, it was important to pay attention
пользователь взаимодействует.
to those parts which the user interacts with. It's even important how the syntax analyzer is implemented. If you ignore it,
Настолько непонятно.
the error messages will be so difficult to understand that users will initiate bug reports.
Там
Now,
в том, что достаточно
we use Bison in the compiler, and the problem there
даже простые конструкции
is that the syntax
очень
description language is quite weak. Even simple constructs are explained using too many
как
rules. If you want to get error
в
handling,
взрослых компиляторах, где
like in
обработать
well-developed compilers,
что
where it can work through the entire file and say you have 10 syntax errors rather than stop on the first ones. This will also have to describe manually in the grammar, bloating it even more. In this case, until R4 presents interest. It has
коробки работает
error handling working much better out of the box and doesn't require any changes to the grammar. But
компилятор переписывали,
when the compiler was being rewritten, it had quite an immature backend for C++. So Bison was chosen instead. I also tried Tree-Sitter. Tree-Sitter
как бы хорош для редакторов
is good for editors
в плане скорости разбора.
in terms of parsing
У него есть проблема,
speed, but
не всегда возвращает все.
its problem is that it doesn't always return you all the errors.
Парсился, но сказать,
So the file wouldn't pass, but we can't say anything to the user about that.
и это он работает.
And that's its standard behavior as designed. And to conclude, we are going to share
обратную связь мы получали от экспертов,
the feedback that we got from experts
какие проблемы у нас еще возникают.
and what kind of other problems we got into. So the first one,
Запустить код
launching code,
это полдела, нужно еще получить этот код, который
can only be done if you receive this code. Users want to do it in a comfortable way. They want to have an IDE, an integrated development environment, and unless you give one to them, they'll start inventing it themselves.
Мы, собственно, с такой ситуацией столкнулись.
From our own experience, we have encountered the situation. The point is that the language development team and the product development team were one and the same team. And after the first versions of the language were implemented and passed to our operations experts, we, with SDK and compiler and utilities that process rules, we passed them on, and the team focused on feature development. But our users quickly understood that with the growth of the number of problems and with the growth of the team, without some specialized IDE, it would be difficult to solve our problems effectively. And because our development team was not able to quickly step in, they developed their own IDE. It was kind of a wrapper over the utilities that they were given to them. And at early stages, it was a purely internal tool with some misalignment happening from time to time because the users didn't have a specification. So experts was getting information about the language piecemeal, and they were implementing it based on their own experience. With time, we started getting more and more requests from the external users, and therefore a decision was made to get rid of all misalignments and to improve the IDE to the state where it could be given out outside. And after that, the IDE has become part of the product. Yes.
Почему разработчикам нужно думать?
Why developers should think about IDE?
Решить проблему.
Because one would think just solve the problem with misalignment and let the other team write it. But the problem is, this doesn't only apply for about the need of alignment. It's also about a need to redoing quite large piece of work. For instance, let's take a look what an IDE user needs. That's the syntax, highlighting, that's auto substitution and code navigation.
Если, например,
For instance,
начинают состоять из нескольких
if
еще переходными
the rule consists of several files, it should also include transitions between files so as not to look for what you need. But the team that developed the compiler
все компоненты, которые
had
либо
components already that allowed
сделать,
either doing it simpler
либо даже
or
лучше. То есть
even better.
логический анализатор
The compiler had syntax analyzer
можно в целом использовать для
that could be used on the whole
подсветку синтаксиса.
to highlight the syntax.
Вот. Так как компилятор может получить
And because the compiler can get AST,
по AST, можно
then you can use this IST to know
текст в том месте,
the
где вводит,
environment, the
и
context,
давать ему только те подсказки, которые актуальны.
and only give them those prompts that are relevant for this context. The compiler has a symbol table in some form or another for validation or translation into the target representation, and so that it can be used for code navigation.
Запомнить.
It's enough to remember the location of all these symbols.
Еще
And there's another,
для того, чтобы
there are also quite a lot of tools to further develop, to further simplify
сейчас во многих
the developer's work.
редакторах
the basic syntax highlighting
описания грамматики.
is implemented in many editors using the TextMate grammar.
Сложные сценарии можно обработать так.
And for more sophisticated scenarios, you can work through the parsing that
Редактора сообщить дополнительную информацию.
will inform us additionally over the editor API.
То есть можно
Editors often have plugin support, so you can write a plugin directly for some more sophisticated functionality. And the most curious thing that appeared just recently is a language server protocol, the protocol of communication between the editor and the program that offers a capability
валидации кода,
to analyze, validate the code.
возможные там варианты
It can inform you about possible options of automatic continuation, regardless of the use.
выбрать.
So there's something to choose from.
Самый мощный, получается,
And the most
написать плагин к редактору,
powerful thing is to write a plugin
интерфейса, но
to save on the development of the UI, but
основную логику уже все равно реализовать самому.
implement the main logic yourself. Language server
Language Server Protocol.
that uses language server protocol,
Средний вариант.
or some other,
Самое главное здесь,
some middle option. The most important thing here
он понимает язык,
that understands the language, so all the specifics related to the language stays
эти команды
within the area of responsibility of the DSL developer team, whereas
все редакторы можно
integrating this to the editor that you like can be deferred to another team. And there's also always an option
сделать свой
to ask users what they need and offer them
библиотечки.
APIs from some library.
Стоит учитывать, что
It's also worth
всегда пишут правильный
mentioning that the user does not always write code
планируется к достаточно
from the first attempt. And if DSL is planned for active use for quite a long time, just like in our case,
как бы за вот все эти годы существования.
so overall, the years that the language has existed, experts wrote thousands of rules,
Подход написать правила и посмотреть, чтобы
and the approach consisting in writing a rule and then see, and then manually checking that it works,
поэтому
to see that it's, and then to commit it.
вкладки. Также
Of course, some debugging effort will be needed.
разработчикам
But on the other hand, they help the developer sort out the bug reports.
вкладки лучше предусмотреть заранее.
The point is that some debugging tools needs to be envisaged beforehand, because later it would be more difficult to add them. For instance, if you want to add an interactive debugger, one would wish that you write some functionality immediately.
Пошагового исполнения, либо
So,
если берете что-то готовое,
or if you take something ready-made, to take a look if it supports the step-by-step execution. But you don't need to rush writing a debugger yourself.
по опыту,
Again, from my experience,
если пользователям не давать,
If
они сами начнут что-то писать.
you don't offer tools to the users, they'll start writing them themselves. And the first thing they will build would be testing tools, some framework
И
to write at least unit tests, and some utilities to launch them.
в нашем случае
In our case,
помогает
what helped
исполнение. Это
was the execution tracing. It's not yet
когда мы записываем
debugging as such, but we record the entire trace, all operations that have been executed, and considering that our rules work in batch mode from start to finish, or it can be all passed by an expert manually. But if you need an interactive debugger, then there's a debug adapter protocol
Для подключения отладчика
to connect the debugger to the interface.
И напоследок
And lastly,
собранные грабли.
let's talk about the pitfalls that we got into when implementing the features. So the first problem that we encountered was about quantifier. With the growth of the number of rules and cases, it became obvious that we're losing in performance. So we started digging where it happens. And after the profiling of the normalizer, we understood the reason. The problem was closed by issuing a recommendation to our experts. After that, they implemented these recommendations as rules. The second story was about base 64. The experts didn't offer practical scenarios to the development of the requirements. Actually, it turned out to be quite a simple thing. But the scenarios turned out to be more difficult. Before passing this string to the input of the function, one needed to enter another string, so it was a substring of another string. This problem was closed through a workaround. They just used a regular expression, and it was out of the regular expression that it was passed to the function input. But the problem is that one might not have had a coded value, and the result of such decoding could issue an invalid sequence of bytes, byte sequence. So the feature was not solving the problem, but a workaround was developed based on the peculiarity of the language. And the developers took practical case and feedback as an input and planned an implementation of a feature that would help solving this problem for the user in a convenient way. And as a consequence, users like problems being solved through the existing tools. If you run into a problem and you don't have new tools to solve them, they will be trying to solve it with the existing tools. And that may affect adversely the performance. So you need to keep track of the growth in complexity at the level of the compiler. So that's basically all we wanted to talk about, the QR code for the evaluation of the presentation. If you are prepared to offer this feedback, please do, and many thanks. Hey guys, thank you. I am joining the audience, and by the way, you'll be able to help the speakers by adding your feedback, but you will also be able to take part in the drawing of the book. Okay, reminding you that yes, there are microphones. Hey guys, please use them. There are two microphones.
Нельзя вопросы?
No question?
Время у нас.
The time is up.
3 вопроса или прям короткие?
Well, very brief ones, okay?
Три руки, давайте прям.
Well, there are three hands. Very brief questions, brief answers, okay? Hi, how does it work?
Все.
I think it doesn't. Hi, super presentation, especially the part about development. And I got a question. If DSL is a tool, is a user tool, have you tried to put an MCP LLM on it so that the user could use the natural language to describe rules so that it should translate that to there? I think that could result in fewer errors. This is up in the air. This idea is up in the air. And as far as I know, the guys are looking in this direction. What I know for sure is that there are experiments so that against a large stream of events, one could form the normalization rules. That problem is surely being solved, and there are even solutions that are being handed out to partners. So on a large flow of events, you issue suggestions on the ready-made formula immediately. Yes, thank you.
Так, вас тогда опередили, давайте побыстрее.
So I think you've been intercepted. Let's try and do it fast. Thank you for doing what you're doing. My question is about the Tower of Babylon. You've listed a lot of DSL and other things. The experts should know all of them. Should one strive for the language only to be to be a single language? So is there any practical sense in this, or one should avoid this? And no adjacent questions. Well, a great question. Look, everything depends on your subject area. In our case, different rules can be written by different people, different teams. And more than that, every rule type has a specificity. If we write something universal that will solve all problems for all services, that will require making it too complex. So it's all practical. We accept a decision that's more convenient to you. In our case, it was more convenient to build our own language with its specificity and its subtleties. Oh, thank you. Next one. Thank you for your presentation. I have a really quick question about IDE. When I was working with language on Linux, using Wine, so I really had a pain in that IDE. And you, in VS Code plugin, I heard that it does exist, but can one, VS Code, can one find it anywhere? The ID that we're showing today, that emerged in the beginning phase of the existing of the language, that was developed for Windows, and there were no plans to port it. So we're now looking at developing a plugin, and there's already a community plugin. And we connect using it to this story in order to help develop this plugin, offering more and more convenient development tools. So our target story is that we go into the is about developing the plugin and provides more convenience for development. And the last question. Haven't you thought about supporting macros in the language and offering users the capability to share these macros? Well, for some rules, we already have macros. For instance, for filters, in the correlation and enrichment rules, I mentioned that situation. It's when the rule starts consisting of several files. But in general, macros is a mixed bag. On the one hand, the user doesn't have to write a lot of code, but on the other hand, they expand into larger code. So basically, we offer a user like a time-delayed bomb. So sometimes they will write a macros that will explode into so much code that the compiler will not cope with. So I will ask everyone who's asked questions to stand up. Hey guys, please decide which question gets the prize. I think the question about the number of mutations in the language, why there are several one of them, why wouldn't one write one and cover all tasks? So, colleague, you get a book from the Peter Publishing House. That's all. Thank you very much.